Hello friends, my name is Kinjal Bhavsar, lecturer in ECP department from PPMP Polytechnic College. Today I am going to explain the subject Principle of Electronics Communication System in Unit 1. Then name of unit is Introduction to Communication System. Then in part 1 I explain the basic idea of communication system. So these are the objectives of my topic. First, explain electromagnetic wave spectrum. Then what is electromagnetic wave spectrum, how to use, application of electromagnetic wave spectrum, etc. Then next, what is signal, then signal and its representation. Normally two types of signals, analog signals and digital signals. Then now, first of all, what is a communication system? So in basic idea, communication system means of conveying the information from one place to other place. That means transfer the information from one place to other. Then information can be different types of, like sound, picture, music, computer data, etc. Then basic concept in communication engineering start from what is modulation, what is demodulation, then noise, information theory, etc. In communication system, normally radio signals are transmitted through electromagnetic waves, and this radio signal are also called radio waves. Then electromagnetic wave spectrum. So electromagnetic wave spectrum have a wide frequency range starting from a few kilohertz to several thousand megahertz. This wide range of frequency is called EM wave spectrum or RF spectrum. So this is the electromagnetic wave spectrum, and this is the wavelength of signals, and wavelength is also related to frequency. Okay, so here this is a long wavelength signal and this is a short wavelength signal, and this waves are divide according to its wavelength. Okay, so in between this wavelength, signal is called radio waves. In between this wavelength, signal is called microwave, and in this range, signal is called infrared signal. Then between 10 raised to minus 8 to 10 raised to minus 11 X-ray, and above this rays is called gamma ray. Okay, so in electromagnetic spectrum, this is a terminology कि very low frequency. तो very low frequency, that means कि frequency range come from 10 to 100 kilometer in wavelength. Then low frequency range, that means ki wavelength of 1 to 10 kilometer in range. Then from medium frequency range 100 meter to 1 kilometer range. Then high frequency range, that means 10 to 100 meter in wavelength range. Then VHF range, that means ki very high, that means ki very high frequency. Then very high frequency range between wavelength between 1 to 10 meter. Then ultra high frequency, the ultra high frequency is range between wavelength 10 centimeter to 1 meter range. Then SHF, that means ki super high frequency. So super high frequency between 1 to 10 centimeter wavelength. Then EHF, that means ki extra high frequency. So extra high frequency 0.1 to 1 centimeter wavelength range. Then at last ultraviolet light. Okay, so these are the electromagnetic waves terminology used normally in communication system. Then this in electromagnetic spectrum, this axis for wavelength, and wavelength is also related to frequency. So relationship between frequency and wavelength lambda. So lambda is equal to c by f, where c is the speed of light, then value of speed of light is 3 into 10 raised to 8 meter per second. Okay, so wavelength and frequency are inversely proportional to each other. That means in this spectrum, when wavelength is low, then wavelength is long wavelength and frequency is low, and short wavelength and frequency is high. That's why it's inversely proportional to each other. Then this is a waveform of electromagnetic waves. So electromagnetic, that means ki electrical plus magnetic field. So in this diagram, this blue signal is electric field and red signal is magnetic field. That means ki electric field and magnetic field is perpendicular to each other in electromagnetic waves. Then next, application of EM waves. So application of EM waves, first of all, types of EM waves. Types of EM wave: radio waves, microwaves, infrared waves, X-ray and gamma ray. So one by one in this application of EM waves. So first of all, radio waves. So radio waves have wavelength that range from less than a centimeter to tens or even hundreds of meter. Then radio waves wavelength of a few centimeter can be transmitted from a satellite or antenna, and reflected wave can be used to form an image of ground in a complete darkness or through clouds. Then use of radio waves. Use of radio wave is to transmit a radio and television signal and to create the image. To create the image of ground in complete darkness or through cloud. So these are the application of radio waves signal. Then microwave. So microwave, that means ki wavelength range from approximately 1 mm to 30 centimeter. Then uses of microwaves in various communication system, media and medical laboratories for testing. Then next wave is infrared. So infrared, that means ki infrared is a region of electromagnetic spectrum that extend from visible region to above 1 millimeter in wavelength. That means infrared radiation can be measured using electronic detector and has application in medicine and in finding heat leaks from houses. Then next wave is ultraviolet waves. So ultraviolet radiation is a range of wavelength from 400 into 10 raised to minus 7 of meters to about 10 raised to minus 8 of meters. Then sunlight contain ultraviolet waves which can burn our skin. Then ultraviolet waves are used extensively in astronomical observatories. Then next wave is X-ray. Then X-ray wavelength ranges from 10 raised to minus 10 to 10 raised to minus 12 of meter. Then high energy waves and used extensively in medical application such as in inspecting the welds. These are the application of X-ray. And at last gamma rays. So gamma rays have a wavelength of less than about 10 raised to minus 12 of meter, and gamma rays are generated by radioactive atoms in nuclear explosion, and gamma rays use in many medical application. So these are the applications of EM, electromagnetic waves. Then next topic is signal and its representation. So first of all, there are two basic types of signal. One is analog signal and another is digital signal. So first of all, what is analog signal? So analog signal, that means ki information that is continuous signal. information that is continuous signal. This type of signal is called analog signal. In analog signal, infinite number of values in a range. Then analog signal varies smoothly and continuously with time. Then example of analog signal is sine wave, human voice. These are the examples of analog signals. Then this is a diagram of analog signal. In general diagram of analog signal, the positive half cycle, negative half cycle, then peak to peak voltage, amplitude, x-axis represent time. Okay, then one full cycle or period. It's a basic diagram of analog signal. Then in this diagram, analog signal is represented in time domain and in frequency domain. Then digital signal. Digital signal that means ki discrete signal, otherwise discontinuous signal. In digital signal, sequence of numbers, each number representing the signal magnitude at an instant of time. Then this is the representation of digital signal. Digital signal in time domain and digital signal in frequency domain. Then difference between analog and digital signal. First of all, analog signal is continuous signal and digital signal is discontinuous signal. Then analog signal represented by sine waves and digital signal represented by square waves. Then example of analog signal: human voice, natural sound, analog electronics devices are example of analog signal. And example of digital signals: computers, optical drives, then other electronic devices. Then analog signal continuous range of value, like this, continuous value, continuous range of value, and digital signal is discontinuous value. Then analog signal record sound wave as they are. Then digital signal converts into the binary waveform. Binary, that means ki 0 and 1. Then analog signal only be used in analog device, but digital signal suited for digital electronics like computer, mobile and more. Then this is the diagram wise difference between analog and digital signal. Okay. Thank you.